Okay, so in second part, I'd like to talk about an E1 lab. Now we already talked about a little bit about the E41 slash F42, and that was SN1 reaction, right? So here, using the same alcohol, we're talking about making E1 products. So again, the same alcohol starts, but we are going to use a different acid, and I'll tell you in a second why. So we use sulfuric acid. Now, sulfuric acid, very strong acid, but unlike HCl, when we make the acid-base reaction and we do a P transfer, so what we do the same thing with the converting the OH to water, which is a good leaving group, but the conjugated base for sulfuric acid is not a nucleophile, right? So that's what the advantage is coming in, but not a nucleophile, but it is a base. So it's a base, and we are going to use that base to make a E1 product. So let's look at the carbocation. So we lose the water, so we make the carbocation. Now, once we have a carbocation and a base, we have to look at different protons. Remember, we remove the protons to make the alkene. So let's look at that process. And again, all these things in the little introduction I wrote. Introduction. Please take a look at that introduction. So I did explain that again in the introduction. So if I look at that carbocation, so I have a carbocation here. First I look at this proton here. Again, we have not a nucleophile, we have a base, the conjugate base of sulfuric acid. So that is going to do a P transfer. So it's going to do a P transfer and makes this more substituted alkene. So we make this alkene. The number of carbons, we pay attention to the number of carbons. 1, 2, 3, 4, 5. 1, 2, I'm sorry, 1, 2, 3, 4, 5. So that's good. So this is the major product. Remember Zoetoif? Now we have other H's that we can remove. There are other H's that we can remove next to the carbocation, right? So we are looking at the carbocation, the carbon that is the carbocation, and we look at the hydrogen next to. So there's a hydrogen here, not this one, but this one. Oh, there's a hydrogen here, so we can look at this. So these three hydrogen and these three hydrogen are the same, so it really doesn't matter. So let's get this hydrogen over here. So we look at the hydrogen here, or proton, I should say. And then we have the base that is not a nucleophile, but is a base. So we remove the H as a P transfer, move electrons between the carbon and H over here. So that makes a minor product. It's a minor product. And it's Hofmann. Remember, this is a Hofmann product. So we have two products for this reaction, actually. Now, if you look closely or listen closely to the tape, the YouTube tape, we can use HNMR that we learned to see how many percentage of that and percentage of this we have. I did not put that on the lab report, but just take a look at it. Now again, like SN1, we have I'll put the paper up. It usually doesn't show up very well. But if I put the paper up for the lab report that you're going to fill and post it, I'll make this a little bit bigger. As I said for SN1, again, this is what we asked the student at Rowan. So we asked student enrollment before coming to the lab, look at the reagents that we use and find from the different sources, density, molecular boiling point, melting point. Please fill out this section, right, the table. Very easy lab report. Then we also ask them to look at their product. So we have two products, right? One is major and one is minor. Again, go look for a molecular weight. It should be the same. Density most likely is the same. Boiling point, melting point, very similar or the same. Then typically like SN1, we have a procedure. Read the procedure. There are two pre-lab questions here. Please answer those. You can do all these by hand. You don't have to type it. Do it by hand. Print the lab report. Put it in by hand. Pencil, paper. Easy. Then please make sure it's a PDF before submitting it on the Blackboard for grading. So this also has 2 pages. On page 2 is the product. So when we went to the lab, we did the distillation, you'll see. So I propose that we use 15 ml of the alcohol and 8 ml of the sulfuric acid. Then we ask what would be the moles. So you can calculate that. Then we make the product. I propose when we went to the lab, we collected 3.76 gram of the product. So that was the combination of 2 products. The boiling point we observed was 34-38. And then like SN1, we have to measure the 100% yield. What was that from dumbbell moles? And percent yield based on this number. Then question number 3 and question number 4, very simple question asked to answer. So just write something here. Again, like before, just do it by hand. You don't have to type it. Again, this is only 2-page report. Please submit it by next Wednesday, and I'll grade it and put the answer right there. So again, this is the second lab that I'm asking you to do before next Wednesday. So this is a E1 reaction, and the other one was SN1. Thank you. And if, as always, there is a question, please text me or send me an email.